Hey everyone, welcome to part 8 of the Azure Masterclass. And this is all about application services. So thinking about containers, which is really everywhere today. Then thinking about, well, containers in Azure. Yes, I could run it in a VM, things like Azure Container Instances, orchestration with Kubernetes and the Azure Kubernetes service, the complete managed offering. And then we'll go and look at some of the app service capabilities like app service plans, Azure Functions, and then we'll finish off on Logic Apps. So when I think about app services, we already covered VMs and virtual machine scale sets. And absolutely, I can run my applications in there. What we're really thinking about here is moving up the layers. We talked before about the idea of pets and cattle, and the idea that, well, Azure always manages the core fabric, the storage, the networking, the compute, and then the hypervisor. With a virtual machine, we get to see, but are responsible for, the operating system, the runtime, the middleware, and then obviously the app and the data. So when we start moving into the true app services, really our focus is all around, hey, I want to think just about my app and my data. And I've got to kind of say, but as always, if this is useful, please go ahead and hit that kind of like, subscribe, and comment below and share. So as I think about the services, this whole idea of pets and cattle is really important. And we move from those VMs to the app services, we really need to understand, well, what is the difference in these things? And so we're absolutely used to the idea of pets. So we can have kind of a pet, we'll make it Garfield. Okay, so with our pets, we can think about, so that's a pet, we care for them. So we think about, well, we would patch them, we fix them. We really make sure if they're sick, we heal them. And then we have the idea of cattle. Now, if it's cattle, we can kind of think about, obviously, not really a great artist. Just to make sure we'll have it saying moo. So that's a cow. So with cattle, we don't care. If it's sick, we just replace. We don't really name them. There's nothing special about any aspect of cattle. If I think the services, well, we think VMs live here, a virtual machine. But in truth, even VMs are sometimes cattle. If we think about things like a VM scale set, we don't really particularly care about any individual instance. That's not our focus. And even with VMs, things like Windows Virtual Desktop, yes, it's using a VM underneath, but we don't care about any of those individual virtual machines. Then absolutely we get to things like containers, and by extension, that includes things like Azure Container Instances and AKS, and we kind of think about the app services. And realistically, we don't want to be in the pet world. Some things are pets. Domain controllers, our SQL server. And what a lot of this actually boils down to, if it's pet or cattle, is I have some kind of state that I care about, and this really doesn't have state. Now you may argue, well, wait, they have state, otherwise it would be completely useless. But it's where is the state? Normally the state is part of the virtual machine, the virtual machine's disk. As we think about these types of services for things like scale sets, and for scale set, we have some external storage, and maybe a data layer, database. Windows Virtual Desktop, we abstract away the profile with the applications. It could be our FS logic, user profile disks. We separate the data from the actual machine. Containers, if I really need something stateful, well, I can have a persistent volume that I can attach and detach from whatever compute instance. So when we talk about state, we're really talking about the compute aspect of it does or doesn't have a state. It's whether or not we have to care about the particular instances. So this is what we're trying to move away from. We don't like the idea of having to care and feed some compute instance. I want it to be completely disposable. The state is separated and anything could just kind of go and connect to it. So with all of these types of things, virtual machine scale sets, Windows Virtual Desktop, containers, app services, the all-up service obviously still has state, but we separate it. We separate it from the compute block. So if the compute block's sick, we don't care. We can just replace it. So let's kind of start with what is the first kind of compute block we always talk about, and it's containers. If I think about virtual machines, a virtual machine virtualizes the hardware. So we're used to the idea of virtual machines. So I can think about, okay, well, we have that physical box. That physical box has resources. I can think about, well, it has kind of CPU, it has certain amounts of memory, it has storage or access to storage, and then it kind of has networking. I have no idea actually what network, not like that. Now with a virtual machine, what we actually do is, well, I create a VM on this thing, and that VM gets a portion of virtual resources. I get some kind of virtual CPU, I get certain amounts of kind of memory, I get virtual hard disks that consume kind of some of that local or remote storage, things like storage count, managed disks, and I have my kind of virtual network adapters that bind to physical network connectivity to go and talk. And inside there's a whole bunch of stuff I have to manage, and I can have multiple VMs on the same physical box. And in there I put an OS, so that OS has kind of a kernel. Then I have a bunch of processes that run in kind of a user mode space. So there's kernel mode, user mode, and these are all just kind of processes. So that's virtual machines. I'm virtualizing the hardware to create virtual machines, virtual piece of hardware, but then I have to install an operating system. The OS has a certain amount of bloat. The OS has a whole bunch of processes and manageability. It takes time to spin that stuff up. But it gives me great isolation. If I have another virtual machine on the same box, well, it has its own OS instance, its own kernel, its own process space, different versions of libraries. There's no conflict between them. And that's why virtual machines are so attractive. Before we had things like DLL hell. DLL hell was all about, well, if I tried to run multiple apps on the same OS instance, they maybe had different requirements. So they would clash with each other. Put them in a VM, they're completely isolated. They can't see each other. The processes can't see each other. They have different file systems. It removes any kind of risk of a clash. So if you think about a container virtualizes the operating system. And what it's basically going to do is this idea that there's many capabilities. Containers itself is not a first-party part of the operating system as such. But there are features in the operating system that are leveraged by containers. Things like C groups. So C groups are all about kind of controlling. I could have a C group to control how much CPU you can use, how much memory you can access, what devices you could see. Namespaces provide these isolated walls. I can have a network namespace to control networking. I can have a process namespace, a mount namespace. And then we have this idea of file systems. And what union means is I can have layers of a file system. And what this breaks down to is this was virtual machines. So then let's take a virtual machine still. So we'll expand out one of these kind of VMs. So now I can run containers on bare metal, a physical box. It's not that common. So this now becomes kind of a container host. Now I still have, and obviously an OS, I still have that kernel. But now what containers give me are these sandboxes, an isolated space using C groups, using namespaces. They use a container runtime. Container D is the common one. And now what I have is this container instance. And I can have multiple container instances. Now, when I think about how the machine is divided up, they are sharing a kernel. Then we kind of have kind of a user space. So they're sharing a kernel, but they're isolated with their own networking space, their own process space. They cannot see each other. So I have this idea of kind of container 1, container 2. It has its kind of processes inside it. It has its processes inside it. They cannot see each other, but they are sharing the kernel. Now they also have constraints. I can control how much resource they can use through those C groups. And what it sees is kind of this virtual layered file system. The container is actually running an image. And this container can run a completely different, we'll say this is image 2, completely different image. Now that image has to match the OS of the container host. So this is now kind of a container host, which makes sense. These are not VMs. They're still running on this underlying operating system. So I could not have, for example, a Windows image running on Linux. It doesn't work that way. I'm still using the OS, but I'm isolating the processes from each other. Now, when I think about these images, it's layers, and this is what makes actually containers so powerful. It makes it super useful. I can think about, well, there's going to be a base layer. Let's see if we change the color. So I have a base layer. This is kind of going to be the OS. And again, there's many distributions and different versions. I pick what I'm building from. And then I might have another layer off of that that maybe adds a certain runtime. I could have a completely different layer off of that from a different image that maybe uses runtime too. And then this one breaks out and maybe has an application in it. And then when I use it, these are all read-only. So anything that I go and fetch as an image, this is read-only. I cannot change it. So it's just read access. What gets put on top of it when I actually create a container is kind of a read-write layer. So when my app is running, my app inside this container, it can do read and write, but it cannot modify the underlying image. It's immutable, it's absolute. And what I can do with these images is most commonly we'll have a registry. Now, Docker has a registry. Azure has the Azure Container Registry, which I'll talk more about. And essentially what we can do is when we make our images up, so this is my app1 image, well, I can actually go and store that, push it into my registry. So now I have my app image v1. I could later on do a v2, a v3, or whatever I want. But it's now immutable, it's absolute. I cannot change that thing. So I could have a dev environment, a production, a UAT environment. These images can completely move through them. I can pull it down from 5 different environments. It's guaranteed to be the same thing. And if you think about it, what was always a pain point with virtual machines? The big pain point was, well, the developer creates the app. They have a bunch of stuff on their machine, and they kind of write down what they think the dependencies are, and then you go install it in prod, it doesn't quite work. They're like, oh, you missed this thing. So, okay. And you have this big set of instructions on how to deploy the app. Well, we don't have that anymore. The developer now creates an image. The image has all of the layers that it needs, the runtimes it's self-contained. All I have to do to deploy this is to pull the image and run it. There are no other dependencies I have to go and pull down or anything else. And we can actually go and see these layers. So let's kind of jump over to a demo for a second. So I'm actually running Docker here. So Docker is kind of one of the most common, if not the standard, when we think about containers. And what I could do is I could quickly go and look, for example, in here and look at, well, what are my images? So, oh, wrong line. So I'm in here, and just a very strange thing happens whenever you try and have an embedded session. So if I run that line, you can see at the bottom, Docker images, I can see all the images on my box. You can see I've got HTTPD. So that's one I pulled down from a public repository. And what you can actually do is I could look at the history of that. And if we look at the history of it, you'll actually notice it shows me the various layers that kind of built up what's happened to that image over time. So we can see it's made up of many different things, files being copied to actually make that image up. And what I'm going to do in this example is I actually have a Docker file. So the way we create images is we have a Docker file, a composition file. So the composition file tells it, well, how do I create the image? So when I go back to that kind of the whiteboard, I had the idea of that base image, but I want to create my own. So I build from something and then modify it, put other things in, maybe remove things. Again, it's read-only, but I can hide things through these layers of file systems and then create my own image. So here I've got a composition file. So I'm building from HTTPD. That's my base image. I'm going to run a command to remove the built-in default web page. And then I have a local folder that I'm just going to go and actually copy into it. So if I jump over here, you can see I can actually go and build my image. So if I run this command, you can see it's running, it's doing these various things, and it's now created it. And I could actually run it now. So when I run the image, so the image is the thing that we build from, running it now creates a container instance and pulls that image into it and then executes the process within it. So if I was to run this command, it's going to go ahead and create that container instance, and that's now running. Now, one of the things you'll notice, I've got kind of this P8080. That maps port 8 in the container to port 80 on my actual host. So I can now actually just go to 127.0.0.1. That's my kind of local page. And there, I'm running against my container. And the reason I'm bad father is this is kind of the first time I took my son on a roller coaster. And yeah, that was the face. And if I click it, I can see the first time we went on Splash Mountain. And click it again, get an even bigger picture. And you can kind of see that in action. So that's the idea of creating my own image actually from this. Now, I can then go and look and say, well, what containers do I have running? And we can see when I run a ps-a, I've got, there it is, there's my bad father. It's actually running that container instance I actually created. You can see it's got a container ID. I can actually copy that and then use that actually as part of some of my other kind of commands later on. Look at that. And I can run that. And now I could stop the container. I could remove the container. I can do all these various things. So right now I'm just going to stop it. And then once I've stopped it, I can actually go in and remove it. So I've killed off that container. Container generally runs a process. And as soon as that process terminates, the container terminates as well. So kind of that's the idea of a container. It's really not that complicated. I have an image that I build from a composition file that includes everything it needs to run, all the dependencies, and I execute it inside an actual container instance, a sandbox with its own isolated namespaces for networking and processing, as its own union, this layered file system. I have that registry. I have a repository of my images. So this is super powerful. Now those registries can be private, they can be public. It's really up to me. So I can have private if I was having my corporate IP in there. I can have public if I'm making something that I just want everyone to be able to see. That registry could be in the cloud, it could be on-prem. There's not really a right or wrong. But you saw how quickly that container got created, because it's not having to spin up a whole operating system. The OS is there already. A container is just using bits of the OS to give it the isolation it needs, and then it's there. Generally, I can spin these up in a second. They're that fast. And I still have all the same resource controls. They're completely portable because of this image. I can run it really anywhere. I just have to make sure the image is running on a container host that's a compatible OS, because it's still using that host's operating system to execute. It's just the file system it sees is built off of those layers. So this is kind of one of the huge benefits of containers. They're much lighter weight than virtual machines. It's completely kind of self-contained. Think of microservices. Microservices and containers go hand in hand. We're used to a big monolithic application where it's this one big thing and it's just running all the time. With kind of microservices, I decouple everything in my application. I have loose coupling. Maybe it's a RESTful API I call between them. But imagine I have some task that needs to be run. I spin up a container, do the task, then it dies. Hey, I've got a stock application. Go and research these 5 stocks. Well, spin up a container for each of the investigations to the 5 stocks, does its job, and then they terminate. They're constantly being created, deleted. So there's a lot of capabilities I can actually do about these. And you saw in my example, if I actually go back a second, so if we jump here, the next thing you could do is, when you've created kind of your container most commonly, is, well, I'm going to put it in that registry. Oh, my bad. Let's get back over. There we go. And this is what I'm kind of doing in these next set of commands. So if I scroll down for a second, go here. I'm having lots of trouble with this cursor. So this is a remote machine, and the problem is it's hiding my cursor from kind of my secondary display, just making it near impossible for me to do anything. Mental note, don't use this again. Let's just scroll down. So here you can actually see what I do is, well, I can tag the image I've connected to my Azure Container Registry. I've got my AZ ACR login. Savaltech is the name of my registry, so savaltech.azurecr.io. I tag it with the name of the registry, and I'm doing images/bad father, and then I can push it into my Azure Container Registry. And again, I can see that full history of kind of my image. So one of the things I would do here is, I created bad father, but I can tag it. I can tag it with versions. I can do many different things here. So I'm going to tag it with this name. And then I can actually go and do things like look at the history. And what you can kind of see on my image here, if I actually make this a bit bigger, if we go up and scroll up for a second, you can actually see So that's all the way up at the HTTPD. I'm just going to run my command again to get it more current. So this is looking at my image, and you can see my commands here. You can see where I actually did kind of that remove of the htdocs. You can see I copied in the folder. So you can see how I actually made my image. So all of this was really built around the idea that, hey, I created an image, and then with that command, I could actually go and push it up to the container registry. And finally, when I was in my office preparing for this session, I found this comic. It's Nano Server Man, but it actually has a whole thing about how containers are saving the world. You can kind of see there. So it's actually comics about containers, if you were really, really bored. So what we have then is I can think about, let's get this attention back. Typically, a container runs a primary process. That's its job. So when the process finishes, the container finishes as well. It's there to do a job. They share a common life cycle. And again, we create them from that immutable image. Now, there are ways to have state. I kind of talked about this idea that, well, it has no state, but that may not be what I need. So remember, these processes could absolutely go and talk to some external storage. They could go and talk to a database. There are ways for just basic containers. I can actually map pieces of its file system to something on the host. So I could make folders available so it could store kind of persistent data. Now, when we move beyond this and we actually start looking at some of the core orchestration solutions, they have better options for this. Additionally, I drew all these layers in. The way this works is it's kind of the idea of a copy on write. I can have multiple containers running the same images. It only actually duplicates the parts it needs to that are unique. So I could absolutely, these could be running completely different images, maybe they're running different runtimes, but it doesn't store the entire image. It understands the idea of the layers. So if I have two images built off the same layer, beneath it they depend on, well, it's only going to store this once. So it is intelligence, and it's really super efficient on how it does that work. So think about container support. Docker. Docker really brought containers to the masses. That's what I was demoing on. There's actually something called Docker Desktop. It's great to learn this stuff, and it even has a mini version of Kubernetes, which is kind of the de facto orchestrator. So definitely recommend that. So management, the management commands, how I interface, that's really become a standard. Docker Registry, again, one of the standards out there for storing those images. Container runtime, there's a lot of different container runtimes. Again, Container D is kind of the most popular one right now. That's what Azure Container Instances leverage. And to be clear, these started off as Linux, but with Windows Server 2016, they added their own set of container technologies in. So I can use the same management interfaces, the same registries, it's got a consistent API. It's using something different underneath, under the covers, but I can absolutely do containers on Windows and Linux. That really is a key point. Hyper-V containers. So this gives me an isolated kernel. So if we think about what I drew here, they share a kernel. That's great if I trust that container. If it's in my organization, it's my host, I'm fine with that. I'll share a kernel. I want the efficiency and the speed of sharing that kernel. I'm not worried about a bad actor running in that process. But now imagine I'm multi-tenant, or maybe I'm super important. I don't want to risk someone impacting me. So this is absolutely the normal model. They share a kernel. However, there is something called a Hyper-V container. So I have the same idea that I have my container host, and it kind of has its kernel, and I run my regular containers on top of it. Absolutely. Then I have a Hyper-V container. So a Hyper-V container actually creates a managed virtual machine. So it is a managed. You don't see it. For example, if I did this locally, I don't see this in Hyper-V Manager. It's designed around containers. So what that means though is it's running its own kernel, and then it runs container 3. So there is nothing about the container that's different. This is not a different version of the image. Container doesn't care. This is a deployment. When I start the container, it's an isolation mode. Hey, I need a Hyper-V isolation. Nothing about the container is any different. It's still a container. It's still running on a container runtime. So in all of these things, there's always kind of this, I'm just going to write container D for fun. There's still a container runtime in all of these. It's just that it's not sharing a kernel anymore because it's the only container running. I don't want to do a complete different host just for this. So that gives me this isolation. So when I think about a multi-tenant environment like Azure Container Instances, which we're going to talk about, the ability to spin up this super fast managed VM, but just run one container in it with its own kernel is super useful. Also, if you think about it, because it's running its own kernel, its own OS instance, well, technically at this point, the container host, this is still a container host, could be running Windows. If I create a Hyper-V isolation VM, this could run Linux because it could be a Linux image and that managed VM could be a Linux managed VM. So it gives me some more flexibilities actually in how I deploy things. So if I need absolute isolation between containers, at runtime when I start the thing, I can pick an isolation mode of Hyper-V, and it will now put it in its own managed VM. It's still super fast. Now, obviously, it's not as fast as if it was just a regular container. It has to create this VM, but it's super thin. It's designed around running a container. Then we have the Azure Container Registry. Now, I'm going to talk about the Azure Container Registry. Again, there's the Docker Container Registry. There are many others out there. But if you think about logically, it provides both private, and I can make things public as well, but it provides this private repository. So that's where I would put my kind of corporate IP, my corporate images I want to use in my environment. I can geo-replicate this. Now, there are different SKUs. The premium SKU lets me geo-replicate it. Now, that's partly for resiliency. Hey, something happens to a region, we always think Azure, we think best practice, we geo-replicate it to somewhere else. That's not actually the biggest reason. So if I think logically, I've got that registry, fantastic. That registry exists within a location. So let's just say this is in region 1. And let's say these hosts, this is all region 1. So hey, the registry is in region 1, container host in Azure region 1. I want the registry close to the host because it's got to pull the image down. If it's half the world away, it's going to be much slower to create that thing. So if I now had another bunch of container hosts, so there's another container host over here, and this time this is region 2, well, I don't want it to pull from region 1. The performance won't be great. Now, it may not be that big of a deal. The images are generally pretty small. But what I can do is, well, hey, region 2, I've got my Azure Container Registry service. I'm going to tell it replicate, which means that image, hey, there's a replica here as well. So when I deploy from the Azure Container Registry and I grab app 1 image, hey, it's in the same region. I'm going to pull the one from the closest region to me. So that geo-replication, yes, it's useful because it makes, it's resilient from the region failing, but I want to have my registry, my repository of my images close to where I'm going to run them. I want to reduce the latency, and also I want to increase the reliability. I don't really want to be going over the internet. the Azure Container Registry runs in Azure, that same local network as where my container hosts are running. So we like the idea of that Azure Container Registry. So we place as close as possible, as I kind of talked about already. With the premium, I can do private endpoints, so I can actually put an endpoint into a virtual network. And I can even run jobs. So I'm talking about storing images. They actually changed the container registry that it can store other stuff, other artifacts I might want to use. I can put in the Azure Container Registry as well that might be used as part of my all-up deployment. But you saw me build the image. I had my Docker composition file. I ran it, it built the image, and I pushed it. That's great if I have all the dev tools locally on my box. So running all of this, the way this really went, remember, was kind of, well, there's my machine, there's me, and doesn't have any hair. And what I have is my kind of my Docker file, my composition file, that kind of had that immutable, that declarative of, hey, I'm building it from this base image and I'm doing these commands. It ran and created the image, and then I pushed it to the registry, to the Azure Container Registry. Well, what I can actually do is I could just say, hey, Azure Container Registry, you do it for me. So I can actually have that up there, and as a job, it builds the image for me up here. And it can even see, well, it's built from some image. If that source image changes, gets a new version, rebuild my image. I don't have to do anything anymore. I don't need my own pipeline. I've given it the composition file. I've told it what it's built from. That job now, if it changes up here, it's going to go and do the work for me. So the Azure Container Registry does a lot more than just store the images. It can actually build the images. It can store other artifacts that I need for kind of that complete picture. Okay, so now let's think about Azure services. So Azure Container Instances. And these can be Linux or Windows, and it's literally container as a service. This is almost serverless computing in a way, because there is no particular container host I have to create that I'm paying for. I literally say, hey, I want a container. I want this container built from this image of this specification, and I'll pay for it while it's running. That's it. It can be built from standard images or my own custom images I create. They can be public or private. Now, the reason it's Linux in brackets today to integrate with my virtual network, it needs to be a Linux base. Windows is coming, it's Linux today. And these are super useful for burst scenarios, or maybe just some very basic scenarios, because again, I pay for it kind of only for the seconds this thing is running. Now in a second, I'm going to talk about something more powerful, orchestration. But one thing I want to talk about now is this powerful orchestration, this Azure Kubernetes service can use ACI. I can actually make ACI look like a node, an infinite scale node to Kubernetes. It'll be tainted. It'll be kind of tainted as, hey, it's not my regular worker nodes. So I will have to add a tolerance to my deployment to use it. But I can absolutely do that. I can actually burst. So think about I had a certain capacity ordinarily. I can burst to this thing as required. So let's kind of have a little bit of fun and try and use this. Remember, I created my own custom image, that bad father, and I pushed it to my container registry in Azure. So over here, if we actually go and search for, oh, there's my container registries, so we can see it. And there's the registry I created. And if I look at my repositories, I can see I've got my images, bad father, and I've just got the latest one. I really don't have any others. So I'm using, this is just the real cheap type of Azure Container Registry. Again, there are different types. There's different levels I can purchase based on what I need, how much data I can store, number of concurrent kind of accesses to it, things like if it supports private endpoints. I don't need any of that. So I have my image in here. So now what I can do is I can go to container instances. Now I don't have any. I'm showing it from the portal just for kind of fun. I can say, hey, create new if I wanted a new resource group, or just for speed. It really doesn't matter what I pick, but I will just pick my South Central. Give it a name. ACI Bad Father. I'm really going all in on this. I can use built-in images. They have like a little hello world. They have some Nginx, which is super powerful. IIS built a nano server. That's what this comic is about, my Nano Man comic. Super thin version of Windows for certain scenarios. Really now just for containers. It used to be maybe running services as well. They changed it to it's built all around containers. Or I can pull from Azure Container Registry, and there's my image, or things like Docker Hub or something else. It knows it's Linux. I can pick the size of what I actually want to run it as. I could also, for networking, I'm going to do public. I could also do private, and I could integrate with my virtual network in that region and deploy it to kind of a private IP. But for fun, I'll do that. I'm just going to do public, and we'll call it Bad Father here as well. And it likes that name. And I can say create. And it pass validation and go. So what this is now doing is it's pulling the image and it's going and deploying it to the Azure Fabric. Now, there is no set node. Essentially, Azure has a whole batch of capacity. So it's finding where it has some capacity in South Central US, and it's going to use this type of container, a Hyper-V container. It's multi-tenant. I don't trust the container running next to me. So it's going to basically create my own kernel. So I'm not sharing that with anyone. It is my isolated, the same way we do VMs in Azure, and it's isolated using Hyper-V technologies. It's the same Hyper-V technology here, spinning up this managed VM super fast, using an OS based on the type of the container, Windows or Linux, pulling down my image, and will execute on top of it. So your deployment is complete already. You saw how fast that was. So even though that was kind of this Hyper-V isolated, how quickly did it spin that up? It's not like a regular VM. It's much quicker than that. So now I can see, okay, my deployment is complete. I can go to my resource. There's my fully qualified domain name that I'll copy. And let's just see if that works. And there it is. So now I'm running me as a bad father, and my son's going to remember this forever, using an Azure Container Instance that's public facing. And again, I'm not the world's worst father, so I will actually go and delete that. But you can kind of see how quickly I can spin those things up. And that's my image. So Azure Container Instances are phenomenal to quickly go and just create something that I need. So it's a container as a service. I pay for when it's running. Very simple. And it can still integrate with my virtual network if I pick that private networking. So now we get into kind of the big boy, Azure Kubernetes Service. Because yes, one container is great. It can do something. It can do a process, and on its own, yeah, I could maybe map a folder from a file system. Yeah, I can do some basic networking, but it's isolated. There's nothing really else about it. We typically need a more complete set of orchestration around it. Now, there are multiple orchestrators for containers. There's kind of a DCOS, there's Docker Swarm, and there's Kubernetes. And honestly, a few years ago, it wasn't clear which one to use. Today, Kubernetes won. Initially, Azure had kind of an Azure Container Service. And what it would do is you got to pick the orchestrator and it would deploy it for you. Well, they've really got rid of that. There's an engine still out there you can use if you really want to create an ARM template, but it's now Azure Kubernetes Service. a managed offering. And the reason we need this is, great, I've got those containers, okay? But is that everything? Do I want one? Probably not. So I probably need some kind of auto scale. I need that. I need kind of upgrades, kind of a life cycle management. And I probably want that rolling. I don't just want to delete it all. I want some kind of rolling update capability. I need to be able to find up the services, like used load balancers, things on there. So load balancing. Multiple instances, I need to put that behind something. Maybe affinity, and more likely anti-affinity. The idea of saying, okay, well, I want 3 containers. I want it spread over 3 fault domains. I don't want it put all on the same box. I want storage. Yes, I'm stateless, but actually I need something that persists. I need something durable. And yes, I have that read-write layer we talked about up here. That read-write layer goes away when the container goes away. Yeah, I can kind of map folders to the host, but what if the host dies? I don't like that. So I want some kind of storage capability, and I want kind of a rich networking set of capabilities as well. There's more to it than kind of just that super simple thing. So all these kind of requirements, and how do I get that? And it really comes down to this, well, I need orchestration. And when we say orchestration, what we really mean today is Kubernetes. Now you might see this actually written as K8S, which I actually thought was because it was Kubernetes. Valid, but that's incorrect. The reason it's K8S is, well, there's 1, 2, 3, 4, 5, 6, 7, 8 characters between K and S. So K, 8 characters, and S. Who knew? So Kubernetes is kind of that de facto orchestrator that we're actually going to leverage as part of our environments. Now, it actually provides a free managed Kubernetes environment with AKS. So Kubernetes itself has a whole bunch of components. It can't just run in thin air. So if I think about Kubernetes, well, there's a database where it has to kind of store information about everything that's going on. That's kind of this etcd, this open source database. Well, it has that. There's an API server. This is our interface in and out of Kubernetes. That's where I make the RESTful calls. That's where I can run command line tools. There's actually a command line tool, kubectl, to actually go and interact with the API server to make it go and do things. Then there's kind of a scheduler. And the scheduler is actually super powerful, because what's going to happen is we're going to request things to get deployed. Well, it's the scheduler's job to notice that, hey, something has been deployed but isn't running yet. It's pending. So the scheduler's job is to go and find, well, where do I run this thing? Put it somewhere, run it, make sure it's running. And it has a whole set of controls. There's things called predicates and kind of priorities. And you can really think about these as kind of hard requirements and maybe soft requirements. So a hard requirement could be you must have this amount of memory. A soft requirement may be some kind of anti-affinity. So if a target node doesn't have enough memory, we can't run it there. That's a hard block. So essentially for predicates, we filter. If it doesn't meet it, we can't use it. We want it to be anti-affinity. I want to spread them out. But if I can't, I don't want to just not deploy it. So this is kind of a sort. So we have a list of possible nodes we can deploy to. We filter it, then we sort it, and then we deploy to the thing. So the scheduler, super important around that. There's also a whole bunch of controllers. So I think about all these controllers. They do a whole bunch of different things. I can think about node health, for example. So they go in and check in on those things, checking about replication, all sorts of different things. But all of these things, if I think about kind of this is kind of this Kubernetes management. With AKS, all of those bits is free. You do not pay for the Kubernetes cluster. It's free, you don't pay for it. All of this stuff is essentially running in kind of an Azure paid for location. It's for you, it's an instance for yours. It's running a certain version. You can say, hey, I want to upgrade to a newer version. So these elements are dedicated to you, but you're not paying for them. It's just there. All goodness, essentially, for that point. Which is why, yes, I could deploy Kubernetes myself. Absolutely. I can have virtual machines. I can deploy Kubernetes. I can read a book on it. I can deploy it and manage it. Why? This is fully managed. It keeps it healthy for you. I can then just use and focus on really what I care about. And what I care about are my worker nodes. And this can actually auto scale. I can use things like VM scale sets underneath. So if that's my kind of Kubernetes environment, and this bit's all free, remember that kube control, again, I use that from my machine to interface, and again, I still don't have any hair, but I'm a bit conscious. I'm gonna put a hat on. So that's how I interact. Where the things are running are on worker nodes. So what we kind of think about is I have worker nodes. Let's say we have 3. I can change the number, but these are my worker nodes. And what I start with is kind of a system pool. And the reason it's the system pool is there are actually some containers to do certain core functions that do get deployed to this, that this has to use for interaction with these. Now, the first thing that's part of this kind of Kubernetes is you'll actually see this kubelet. I can't spell. So on every one of these, I really can't spell today, is a kubelet. You know, I spelled it right the first time. Third time's a charm. So the kubelet is actually what talks to the API server. That's how this Kubernetes cluster, remember this is Microsoft, this is you pay for these worker nodes, they're just VMs. You pick the size, you pay for those. Remember, these have a kernel, so they have kind of the kernel. Actually, I'll draw a different color. I don't want to draw that color. So once again, it's an OS. This is a VM fundamentally. You don't see it as a VM, but they're running the shared kernel on all of them. Once again, they're running that container runtime on all of them. And then it just creates your containers. Container 1, container 2, container 3, container 4. You get the idea. Containers everywhere. There is another component that's kind of built in on each of these nodes. There's also something called kind of kube proxy. Kube proxy, KP, is all about networking. So that kind of helps it interact with the various types of networking I will have in that environment. And as I talked about, remember there's ACI out here. This infinite kind of scale on demand. And the way that works is kind of in my cluster. This kubelet is how we talk to things. Well, it actually creates this virtual kubelet that it can talk to and then instantiate things on Azure Container Instances. So I can do that as well. But that's what Kubernetes service is. There's nothing magical about it. Azure Kubernetes service is, hey, I have the management, all these orchestrator things, and then I deploy. And again, it's the scheduler's job to deploy these things. Now, I said we're running containers. That's actually not strictly true in terms of Kubernetes. Kubernetes really doesn't care about containers. What Kubernetes does is it actually deploys, I want a different color. Let me change color. No, that's not good. Oh, my whiteboard crashed. All right, let's spin that up again. That never happens. All right, there we go. We're back again. I think I draw too much stuff on the whiteboard. All right, so see if I change my color again. There we go. What it actually does is it deploys a pod. So I can think really about the idea that, well, we have a pod. The pod runs, generally it's a kind of a one-to-one, a container. And that's actually not true. It's actually very common to have something called a sidecar. Sidecar is something that helps that main container do its job. In fact, pods always have at least one sidecar that owns the networking of the pod, because this pod has its own network, like address. That's a big part. So what I actually deploy are pods. So all of these containers actually sit inside a pod. And it is the pod that I actually deploy. So when I'm doing this kube proxy, that's for the networking side, this kubectl, what I actually do is I have a YAML file, yet another markup language. In the YAML file, I basically have my deployment of what I want the desired state. So I don't care about really anything. I'm saying this is what I want my desired state to be. So it's a desired state configuration. I want a deployment of, I want 3 replicas, or 2 replicas, or whatever it is, of kind of this image. Go and make it so. And under the covers, kubectl talks to the API services. This is what we want to be reality. And then it goes and creates deployments and replica sets and stateful sets. The scheduler is told, hey, look, there are these pods that have been created. They're pending. The scheduler's job is to go and look at the nodes, look at these predicates, look at the priorities. Where can I put them? Instantiate them somewhere. And then they go to a running state. And then all these things keep an eye on it. If a node dies, well, it goes and recreates them on other boxes. That's the job of this. So let's kind of have a look at this. So if we jump over to Visual Studio Code. So in here, I actually have a basic AKS configuration. So let's first actually go, and we can see I have actually a couple of Kubernetes services. I have one for container network interface and one for KubeNet. I'll talk about that in a second, but not very much. And on this right now, so this is something you can see. If I look at my workloads, you see all of these? These are core things actually to Kubernetes. If I look at things like my node pools, I'll talk about this again, I can see, well, yeah, I've got kind of my node pool. I have 2 nodes in that node pool. I could change this. So I could actually do a scale. Notice I could upgrade it to a newer version of the Kubernetes. If I go to the overview, my Kubernetes is running a certain version. I can upgrade the Kubernetes cluster. Now, I just upgraded this yesterday so that there isn't a newer version for me to actually run. I would upgrade the Kubernetes service. Then I could update the node pool. So that would be that kube that was running on each of them. So it matches my Kubernetes service. I can see things around sort of various capabilities I can integrate in. But right now you can see I've got my node pools. I've got various configuration items there. I'm running. Oh, there's actually a newer one already. Look at that. That's funny. So since yesterday, there's now another one. Do you know what this might be? There's only so many upgrades you can do, skip at a time. So because I was behind, I think what it's done is, well, now I upgraded my cluster. Now I can upgrade it again. So I'm responsible for picking when I want to do that upgrade. There are some automations I can use, but hey, I could at this point say, hey, I want to upgrade my cluster. I'm not going to because I want to use this. I don't want to risk it doing any kind of getting in the way of those things. You can see I've got role-based access control that integrates with Kubernetes roles. I can enable AKS managed Azure AD so that pods can actually go and integrate. I've got various scale capabilities, but that's actually as part of the node pool, which I just showed you. But right now, if I look at my node pool, this is kind of a system node pool, which means it runs all those standard things that Kubernetes needs, but I can also run my own applications in there. So what I'm going to do is, in this environment, I've installed the kubectl. So I can run this AZ AKS install CLI, and it will add the kubectl to my box. If I look at, oh, wrong key. Let's look at this again. If I run my cluster info, let's make this a bit bigger. I can see, yeah, there's my cluster running, all good stuff. I can, for example, let's get my node. I can look at what my nodes are. And yep, I can see I've got my 2 nodes running in this cluster. This is how you integrate ACI, Azure Container Instances, as now becoming a virtual node. I've also connected my Azure Container Registry to this cluster. Because what I actually did is I've got 2 clusters. And what you can do is, if I look up, I can get the credentials for each cluster, so I can actually go and integrate with it. So what I want to do at this point, if I was to look at all of my pods, I don't have any in the default namespace. All I've got running are system pods. So now this is a YAML file for a deployment. Now I'm not going to go into detail of this. There's too much to it. But essentially, I'm doing a deployment. You can see the kind is deployment. And I'm doing a specification. I'm saying I want 2 replicas. I want to match the Azure Bad Father web. And then I'm using a template, and I'm going to label this template Azure Bad Father web so it will get used. And then the specification is, hey, I want to pull my Bad Father image from my container registry. I'm specifying the resources it can have. Then I'm exposing port 80. Now I have 2 instances of this. So the other thing I need is a service. And for this is part Kubernetes. My service is actually going to be of type load balancer. So it's going to use an Azure load balancer. And it's going to be by default external. So I have annotations to help control things. If I wanted it internal, then I would comment out the top line and uncomment these 2 to make it actually now integrate inside. But as you can see, it's basically going to create 2 pods. So now if I jump back over, we'll just deploy it. So what I'm going to do is apply my desired configuration. My desired configuration says, hey, I want 2 replicas of my image. So here I can select this. I'm going to run it. And it says, okay, there was a deployment created and a service created. So that was kind of super fast. If I now go and look back over and I look at my workloads, you can see there's Bad Father 2 of 2. age is 20 seconds old. If I look at my services, we can see, well, I've now got this service for Azure Bad Father Web. I can actually see an external IP address. And what that's actually doing behind the scenes is an Azure load balancer. Now, the networking of Kubernetes is actually pretty complex. I'm not covering it here. At a super high level, I talked about that kube proxy. Really, there's two models of networking. So when I think about my networking, it really boils down to the IP addresses used within the pods. So I can think there's something called KubeNet, where the pods have to get natted IPs. So there's an IP space within the hosts that is not routable on the overall network. So there's a special route table gets created on the network that drives that space, and then it does natting so they can actually go and talk to things externally. Then there's CNI. Well, with CNI, it's just they get IPs actually from the subnet directly. There is no natting. It's not necessarily one is better than the other. For both of these, I could create a new VNet. I could use an existing VNet. If I have containers that are constantly being created, deleted, created, deleted, created, deleted, do I really want those using real IPs on the network constantly? Maybe a bit messy. So maybe for me, the natting might be the right option. I have a separate video on this where I talk for, I think, nearly an hour just on Kubernetes networking. I show you how it integrates with the Azure load balancers, how I can use Azure App Gateway, how I can use Nginx. I talk about all of that stuff. So if you want to know the internals of networking, you should go and check that out. But essentially, this has gone ahead and integrated with the Azure load balancer and is now there. So again, if we go over to this, I can see, well, there's the external IP. If I select that, there we go. So now it's me as a bad father running over two different pods with a container in each pod running my terrible father website. So really am stressing how bad of a father I am, and it's just available. If we were to go and look, if I now look at my pods over here, I can see I've got two pods running. I can see the IP of the actual pod. Because I'm using CNI, that's an IP address actually from my underlying virtual network. It's not natted. I could also go and look at the services, which is going to tie to my Azure load balancer. Here I can see the load balancer that I'm using and that external IP. I could get details. I could see the actual endpoints. I can really see all of the different pieces of information. And then when I'm kind of done, well, I could change that deployment file, maybe change it to 3 replicas. It's declarative. It's just going to make that state so, or in this case, I'll remove yet more evidence of me being that terrible father from the internet. So that's the idea behind this thing. It's this declarative state to drive what we're actually doing. Now, I guess I should mention storage. So I talked about the networking. What about if I want persistent storage? How does that kind of persistent storage working? So if you think about, well, you've got kind of these pods. So I can think, okay, great, I've got this pod and the container, but I want some real storage. Now in Azure, there's a whole bunch of different types of storage I can have. There's things like Azure disks, so managed disk. There's things like Azure files, so SMB based access. There's things like Azure NetApp files. So these different types of kind of durable storage actually available in Azure. So what we can have is we can have kind of a persistent volume. Persistent volume is kind of created using a provider, and I kind of have those types available to me. And then we have a particular pod can have something called a persistent volume claim, which maps to a particular persistent volume. So that's how I can now say, hey, I want some durable storage made available to me. I don't want to map it to the host. The host would go away. So if I actually want persistent storage of something, well, I can have these persistent volume claims, which map to a persistent volume that's using a various storage provider that are now available to me. Nodes on the same work node, pods, could actually go and share storage. But that's the idea if I want that kind of shared persistent durable storage available to me. I can use one of these kind of Azure types that AKS actually has storage providers for. And then I can create persistent volumes, a specification of what I want, maybe size, performance. And then a persistent volume claim maps to those so I can actually use them. So that's how I can get durable storage in my environment. Special cool stuff. I can have multiple node pools. So I showed you I had a node pool, and I said it was actually the system node pool. So the system node pool has a whole bunch of Kubernetes things, and I showed you those in the portal. In the portal, remember, we saw the workloads. There was a whole bunch of stuff. And if you actually look at the pods, there were a whole bunch of pods that it was actually doing. So these are things that help it run. But what we can actually have is, well, I could add additional node pools. So I can pick, hey, is it Linux? Is it Windows? This would drive the types of containers I could run. Remember, this is not using Hyper-V instances. The image used by the container has to match the underlying container host, that worker node. So I can pick, hey, okay, I want these things. What's my max scaling? How many nodes do I want? What size are the nodes they should be? Linux, Windows. And these would now just be user pools. And the benefit of the user pools is, well, they're not running any system components. Technically, I could actually scale those down to 0. And while I'm thinking about it, I'm going to upgrade my cluster to the latest version and save. So in the background, it will go through and actually upgrade my cluster. So I can have multiple node pools. I can also use ACI, as we talked about, and I can also use spot instances. So we think about, okay, I drew that picture. So all of these things here were in kind of that system node pool. So all of the nodes are the same spec in there. So there's things running, pods running things that Kubernetes needs, and I can deploy my apps to it as well, which is what you saw me do. I can also use Azure Container Instances. This is phenomenal for bursting. I have a typical normal workload. I'm going to run those on my worker nodes. And I cannot only do ACI. If you think about it, I have to run the Kubernetes thing somewhere. Today, I have to have at least one node in my system node pool. I can burst to ACI, but maybe I need a different spec. I want a different type of Linux versus Windows. Maybe I'm running some containers that want to use more advanced physical GPU capabilities, for example. So I can actually create other node pools. I can have a bunch of other workers of a different spec. These are spec 2. And that's kind of user pool 1. I could have user pool 2. And again, they would have the same kubelet. They would report into the API server. And now I would be able to select as part of my deployment. Remember, I have the taints and the tolerances. I could say, oh, I actually want to go and deploy that to user pool 1. I could control that. As part of my pool, I could, if I want, say, actually, I want these to be spot. I can't mix it. They're spot or they're not spot. Everything has to be. Remember, spot are the much cheaper resources, but they might be taken away from me. It's spare capacity, and I talked about that in the VMs, so I'm not going to talk about that here. But maybe if I had certain workloads that, hey, I want to run, but just as cheap as possible, if they go away for a period of time, I don't care. Or as part of my deployment, I would say, well, if they go away, I'll go and run them somewhere else. I can use Spot to host those instances. I have that capability. I can actually, this is in preview as I'm recording this, I can actually stop and start my cluster. So remember what I said. If it's a user pool, we can change the scale at any time. I can go into the portal, and in this portal right here, I can change my scale. So I could go in and, sorry, not in there. It's in node pools. I could pick my node pool. You can see my node count is 2. I could select that, and I could change it down to 1. There's also auto scale capabilities using VM scale sets underneath. But I can't scale it below 1. I can't scale it to 0. Now, if it was a user pool, I could actually scale it to 0. That's allowed. But I have to always have at least one node. Now, what if this is kind of a dev test, and I just want to shut the thing down and stop paying for that worker node? So what they've introduced is the ability to actually stop it. Now, again, this is preview today, but with a very simple command, you can actually stop your cluster. And I've stopped, so I've got 2 clusters running here. The portal doesn't really understand this today, so I don't think you're going to see anything different. But this KubeNet 1, oh, actually, you can see it's a node count of 0. So you can't ordinarily set it to node count 0, but I have stopped this cluster. So essentially, it's down. It's not running anymore. We're going to look at the workflows. I've never actually tried looking for the portal. So it's error. It doesn't understand. So I've actually shut this down at this point. So we have that capability now to actually stop it. So I can completely stop paying for everything. Remember, we never pay for the management anyway. It actually has auto healing. So this is interesting. Remember, I don't care about this part. That's Azure's responsibility. But my worker nodes, I do care about. Maybe if the node is sick. So what would fix any problem on a node? If you try turning it off and on again. So correct. If it detects it's sick, it will turn it off and on again. If it still detects it's sick, it will try and re-image it. If it still detects it's sick after that, it will delete it and spin up a new node completely. So there's a certain amount of auto healing it will actually do. So there's these constant health checks. And if the node reports are not ready on consecutive checks, I think it's for 10 minutes, it will first turn it off and on again, then re-image it, and then, hey, we'll just create a new one completely. And then we have managed identity use. AKS always uses a managed identity so it can go and interface with things like the Azure Load Balancer anyway. But there's actually like open source projects, there's integrations to actually let the pods use a managed identity so it can go and talk to other Azure resources in a controlled manner. So AKS is, I mean, honestly, it's phenomenal. Containers are going everywhere. If you look at things like Azure Arc talks about bringing data services to any cloud you're on premises. Well, Azure Arc is 3 things. One is management of VMs and inventory and tagging. Part 2 is it will manage your Kubernetes cluster, and it can even deploy AKS to your environment. Those data services it delivers, well, it does by doing a kind of GitOps. And what it will actually do is it does configurations to say, hey, worker nodes, I want you to look at this container registry for your config. As things are kind of pushed there, pull it down and start running it. So the way it deploys data services through Azure Arc is it actually uses Kubernetes to do GitOps. So it's not DevOps, it's GitOps. So it points them to a certain container kind of registry and a Git library for configuration. So it's working together. So there's a Git repository like Azure DevOps or GitHub. And it then uses a registry for the images. And it basically tells the worker nodes that say, hey, your configuration, your config, well, yep, there's kind of a Git repository up here with your config in it. You go and check that for your config. So that's GitOps. and then it will just deploy those deployments, those YAML files that I configure, and pull down the images from the container registries. That's how I can deploy data services. Containers are everywhere. Pretty much everything behind the scenes now is containers, containers, containers. You may wonder why I would ever have more than one AKS cluster. I can have multiple node pools. Well, remember, the cluster runs a certain version. As you just saw me, I went and upgraded it. So I may want at least a dev and a prod, so I can test upgrading the cluster, and then I can go and upgrade the nodes kind of separately. If something crashed on the cluster, it wouldn't bring down the nodes. The workloads would carry on running, and this should heal. But just think from a resiliency, this is running a version. And note, you are responsible for saying, hey, go and upgrade it. So if I go back to my my CNI, and I went to my configuration, so I'm now current. So next things I would now do would be going to go to my node pool, look at my nodes. Oh, there I am. I'm running 1.7.11. Hey, I could now upgrade to 1.18.8, just so you can see that. So now I can do my upgrade, apply, and it will now roll that out to all the various nodes. Okay, so containers, super good. App service plans. So this was the original platform as a service in Azure. This is where it kind of all begun. And it's really all about web apps. So something talking over HTTP, it could be obviously HTTPS. There's also things like API apps and mobile apps, but they're really just some additional things, mobile apps, for example, around pushing and some replication of things. But it's really just a web app. There's a wide range of runtime supported in these app service plans. So in the app service plan, I create an app service, and I can pick, well, what is the runtime I actually want to build that off of? So if I go to my portal, and if we jump over, let's go and look at our app services. So go home. I can look at my app services. If I just create a new one, what we can see here, notice I can run a Docker container. I can actually run containers, and I'll talk more about that in a second. But these are all the stacks it supports. So I can run .NET Core, ASP.NET, Java, Node, PHP, Python, Ruby. And obviously I can write all those things on those runtime stacks in many, many different languages. So a huge set of capabilities and runtimes actually supported within this. I can have both Windows and Linux running on that container or not containerized. You might use a container if you think about it, a web app, it's platform as a service. There's a lot of flexibility in those runtimes, but maybe I have a dependency that is just not supported by app services. So what I can do with a container is I can really do anything I want within that container. It's my container image, so it gives me more flexibility. Even the container still has to be HTTP based though. So that's kind of the constraint around it. But I just get more flexibility. So if I can't get what I want, maybe I can't access a certain type of thing. There are restrictions with app services. If I can't get to what I want to get to, there's some dependency I need. Well, if it's HTTP based, I could run it in a container. So the idea here is I have a certain number of nodes, and then I can auto scale if I have a standard or above plan. So there's different types of plans. So I'm still paying for nodes. I don't see the OS. This is PaaS. I get the app and my data. I don't see runtime, middlewares, OS. I'm not responsible for any of that stuff. It's managed for me. But if we look at the number of nodes, there's different kind of specs available. So the way the pricing works is essentially there's different types of environments. There's actually free. So I can pick free. I just want to play around with this. You get a certain amount of CPU minutes a day, 60, a certain amount of RAM and storage. Then I can do a shared, a bit more CPU a day, storage. But these are free. Like from what I found, I couldn't do like get push. One of the nice things about the basic and above plans is to actually deploy my code I can do a git push. I don't have to FTP. I can just have my repo and push it, and it'll do the npm start, everything it needs. Then there's basic plans. So notice I'm basically picking the size of the VM. Now this doesn't have auto scale, it doesn't have traffic management. Traffic management means I can't interact with things like Azure Traffic Manager to have multiple instances across different geographies and balance it. But I can see, okay, the bigger it is, the more I pay. Then I can see, well, I have standard plans. This is for production. This is where I get like load balancing support. I don't have that in the others. I can have auto scale based on my traffic needs. I can also have Linux runtimes with web app containers. Then I can have premium plans with higher ratios of compute and memory, etc. Premium v3, Windows and Linux based containers, higher scales, isolated. There isn't anyone else kind of on me. So these are in a dedicated environment in the Azure Data Center. If I need that kind of isolation environment. And I have all these different kind of capabilities. So I pick the sizing really based on what I need. So all those great options. And essentially I can have multiple applications deployed to the same plan. So the plan is where I specify the resources. So the first thing I do is I create an app service plan. So I can think about with app service, I have a plan. And my plan is, okay, I want 3 instances. And again, depending on the plan, I could have auto scale, things like that. They're of a certain size. That's my plan. And then into it, I can deploy app services. So then I deploy app service 1. Well, it runs across those nodes. I can deploy another app. So now I deploy app service 2. It runs across the same nodes. Now the decision on whether or not to deploy to the same plan is, well, how much resource do I want to guarantee that app gets? Could it be noisy neighbor and kind of get in the way? So that would drive a lot of those decisions around there. But now I can, again, if I scale out, all of the apps in that plan scale out. It's not like, oh, I add a 4th node just for app service 1. It doesn't work that way. I scale the plan. Everything in the plan will scale with it. We can see this. So let's go back over here. So this was kind of, I was creating a new app. And you actually see when I deploy, if we go back over, it would pick a plan. But if I jump back for a second, I already have a plan. I can see I've got this demo plan over here. I can scale out, so I could add additional instances. I only have manual scale because I'm running a cheap plan. I can also scale up. So scale up is actually pretty interesting. That's not normally something we can do, but what it would actually do with the app service is these are a certain size. If I say scale up, it'll actually create 3 new ones of the new size, spin up my apps on them. Once everything's running, it will then delete the old ones. So it doesn't actually scale them up. It just creates new ones in parallel, gets everything on them, and then deletes the old ones. And obviously you can scale out and in. I can add new instances, I can remove them. But to this point here, so you can say, okay, yeah, I can scale up, I can scale out. That's of a certain configuration. I can see the sizes I have, all these different, and it tells you kind of the features. So I'm kind of on this basic one. I can have a custom domain, I can have SSL, I can do manual scale. Then they have kind of the production, and again, it shows you the features. Auto scale, staging slots, I'll talk about that in a second. daily backup, so it will actually back up the app and the configuration that's mapped to the app. You might say a lot of times, why do I need to back this thing up? I'm pulling it down from a repo, my source code. I've got continuous integration, continuous deployment pipeline. I don't care about the backup, but there's other configuration that goes into this. So having that backup is useful. Notice it includes things like traffic manager. So I can have multiple instances and then balance between them at a kind of geography level. And then to the app service plan, I deploy apps. Now I have an app deployed. This is a Node.js application. Bad father. I did that already. Now for this, I had to FTP it up because this is a cheapo plan. So I FTP'd it up and then I did an MP, restarted it. But even on the cheapo plan, there were various tools, like I can do a Kudu Lite, I can do SSH. And what I now have is this Node.js application. I can go to my Node.js application, and now this is running on PaaS. So you saw me being a bad father on premises with a local Docker file. Then I used Azure Container Instances. Then I used AKS to have multiple instances of it over different worker nodes. Now I'm running it on a true PaaS. And once again, I can click through. And I want to thank, I'm really not a developer anymore. So my good friend Tim Aronki actually created this for me. And so this is a little Node.js application. And I can just cycle through, seeing the sheer terror in my child's face whenever I want. And you know what? This one I'll probably leave up there for you. So if you really want to go and experience the sheer joy of that, you can do that. So, I'm a terrible parent. We have that capability. So we run app services within our app service plan. So some of the special features, so I can scale up, I can scale out. I talked about that already. We have deployment slots. So those better plans have deployment slots. Now I just drew this picture, app service 1 and app service 2. With deployment slots, I can actually create, maybe for app service 1, maybe this is the production, and then I'm going to have app service 1 staging. Now it uses the same set of resources. It's not a different set of nodes. So here, my deployment slots still use and share the same resources as everything else. It's important to kind of think about that. But here, this is running V1 of my code. I deploy V2 of my code here. I can test it. I can warm it up so it's ready. And essentially what I can do is, what I see is these are kind of networks. There's kind of DNS names for each of these. I swap them. So when I'm ready, staging becomes prod, prod becomes staging. Just flipped it over. If something's gone wrong, I could flip them back. I can roll back super easy. So depending on the plan, I can have multiple deployment slots to really make it enable me to warm up the code, roll things back. Gives me things like kind of those deployment capabilities, how I think about rolling out my code. I could have a certain percentage go to staging, 10%. It gives me maybe a blue, green, just switch them over. It enables a lot of those kind of capabilities. We can use service endpoints. So we're going to talk about that in the networking module. I'm not going to cover it here, but essentially there is a Microsoft.web service endpoint. So on the app service, I could restrict it just to certain subnets, being able to talk to it. Also, it can fully integrate with virtual networks. I can use a private endpoint as an IP address in the virtual network to talk to it. I can use things like Hybrid Connection Manager. There's a VPN option, or there's regional network integration, where it does subnet delegation, but it doesn't peer to, I can't go cross region, is the only downside today. But now it has a subnet actually in your network, and it uses that to talk to things in your network. So it goes that way. And again, I have a full massive video going into all the detail. Watch that if you want to understand that. There is something called an app service environment. So I talked about app service plan. There are shared elements. The worker nodes are yours. If you look at an app service plan, outside of that, the free and the shared ones, they are your nodes. No one else is on them. But there's other bits that make an app service plan work. There's kind of some front end services. There's kind of some file kind of share services. There's other stuff. And that is shared. It's one of the reasons that some of the network integration is difficult for app service plans, because it's multi-tenant. These things are shared between different tenants. These are yours, not shared. The other bits are shared between, there's like load balancers, there's IP addresses. They're shared between multiple tenants. Well, with the app service environment, it's not shared. All the bits that are normally shared, they're dedicated to you, and it deploys into your subnet, into your virtual network. So it makes the in and out communications much, much simpler. But obviously now I'm not sharing anything, so it costs more money. It also does have a bigger scale, so there are benefits there as well. Okay, we're on the home stretch. Azure Functions. I love these. So this is serverless compute, ordinarily. So when I create a function, I can pick the plan. There's a consumption plan. Consumption plan, I'm not paying for any underlying resource. It spins up something when it needs it to do my computation cycles, and it goes away. I just pay for the cycles that it uses. But if I have an app service plan, it can run in the app service plan. There's also kind of a premium option where it's going to start a bit quicker, because obviously it's not running ordinarily. It's waiting for some trigger. Things like serverless, they have to be triggered by something. Maybe it's some kind of event, a schedule, manual, event grid. Event grid is phenomenal for serverless. If I think about, I might have all these kind of event sources. A little bit off topic, but this is me. So you can think about, there's kind of event sources. And that could be, hey, someone creates a blob, someone creates a subscription, someone creates a resource group, there's a huge number of things that can create sources of events. And then we have the idea of event handlers. Now, event handler could be an Azure function. It could be a logic app, which we're going to talk about. It could be like an Azure automation. Or it could be any kind of like HTTPS, TTPS, like REST call, anything else. Ordinarily, if I write one of these things, I have to go and poll. So pull, say, have you done something? So they call it like a hammer poll. Have you got anything for me? Have you got anything for me? Have you got anything for me? What Event Grid does, so in the middle here, I have Event Grid. So Event Grid does the job of connecting to all these things. And then what it will do is it will push out to a handler that is registered for whatever those event sources might be. But it can also do filtering. I can say, well, I only want to know about this type. It will do things like retry. So yes, I could write something to just maybe trigger off if a blob gets created. But with Event Grid, it has retry capabilities. I can add filters in. I can have multiple things being driven off of it. It just gives me more capability. So this kind of integration with these event sources and event handlers, and again, I can't even remember, there's so many different types of things I can do over here. There's a massive number. They're trying to get nearly everything can trigger via, like Key Vault. One of the things they just announced was Key Vault can now trigger via Event Grid, so I could find out if a secret's changed. So with serverless technologies, this is phenomenal because they can all act as event handlers to actually consume what's going on. So with the function, it's event driven. Again, some sort of HTTP, HTTPS event, could be a schedule, event grid, blob creation. I have all these options to actually leverage these. In addition to the trigger, I can bind. So I can bind to inputs, other things I want to go and get, and I can bind to outputs. Many types of service can be an input and an output. So you could think I could trigger based off maybe an event grid. I could bind maybe to blob as well to go and pulling an image, and then maybe I go and push a result to a Cosmos DB, output binding to a Cosmos DB database. There's a huge support of runtimes. So if we actually look at this, and I can actually run containers in here, which is kind of insane. But if we look at the runtimes and languages, if I scroll down, what I can see here is, well, I can use C#, JavaScript, F#, Java, Python, TypeScript. And the thing I love, and I use this all the time, is PowerShell. And that's just because I'm an infrastructure geek. But I now use this instead of things like Azure Automation. I will actually fire off now PowerShell I need to run based on a schedule. So it uses a cron format timer. I also have like a RESTful interface that I can call. So I have a whole bunch of functions just to trigger, and there's templates built in to really help me have all of these different things. And I actually get a bunch of executions for free. So I can actually just say, oh, okay, it doesn't actually cost me anything. If we quickly look, so I'll go over here. If I go and look at where's my function? So if we go and actually just create a new resource and we say function app, create, we can actually see here the runtime stack, those different options. We can see it says, would you want to create a Docker container? So I can actually base it off of a container as well. I can deploy it to a certain location. For me, right now, I have a bunch of different ones that I've created. But you can see for this function, it has a managed identity like everything else. So I integrate with things like Azure Storage. It automatically signs in as that managed account. If you turn it on, I don't actually have to do anything. This is from the PowerShell. But I just wrote code to integrate with storage and queues, and I get triggered via a RESTful integrator. If I look at my integration is I have a HTTP trigger. Then I run my function, I have other inputs, and then I have various outputs. For mine, it's just a HTTP. You could have other ones, absolutely, that run on a timer. So when you create these, you actually go in and pick all of that kind of stuff. So here, if I said add, you can actually see, well, okay, where do you want to deploy this? But there's a bunch of templates built in. So based on the language, you can see HTTP triggers for F#, C#, timer triggers, queue triggers, a whole bunch of samples built in to actually help me get started if I really wanted to. So super easy to actually get going. And then I write it in the language I'm used to. So C#, JavaScript, whatever I want to use, I can just kind of leverage that. But again, it can be serverless. I just pay for what it's running. There's like a premium version where it's pre-warmed up, cost me more money. But then I can use like private endpoints as well. Or I can just, if I have an app service plan already, I can run it on top of that. Finally, we have logic apps. So this is a graphical based orchestration. I think of my business logic. I want to do something. And again, I have some trigger. It does something and there's some kind of output. There's both a serverless and I pay only when it's running. So when I talk about the paying options, let's quickly kind of look at those. If we jump over again. So when I look at the logic apps pricing, what I actually pay for are the actions it performs. Then it has connectors to things. And there's both standard and enterprise type connectors. Every time it uses an enterprise connector, it costs a bit more than a standard connector. There is this idea of a fully isolated and dedicated environment. At that point, well, I'm paying for it kind of on the hour because it has to spin this up and it's sitting there waiting for me. So no matter if it's doing something or not, I'm paying this amount of money just for it to be ready. But ordinarily, I just pay for the actions it performs and I pay for kind of what it connects to. So I talked about the integration service environment. So it's initiated by a trigger, some event. And again, it could be event grid, it could be HTTPS call, it could be someone tweets. That could be a connector. So someone tweets, oh, someone's tweeted, I could go and do a sentiment analysis and then maybe write something about, oh, good tweet or bad tweet. There are many connectors and templates to help me get started. So if I quickly jump over and we look at this. So I actually created a blank one, so there's nothing in it yet, but I did create one just ready. So there's a logic app, but it's empty right now, so it's going to jump to the designer. Notice it shows me the triggers I can start with. These are the common ones. There are others. But it's like, well, a message is on a service bus queue, HTTP, someone tweets, event grid, woohoo. File is added, FTP, a OneDrive, a recurrence. Or again, I don't have to use any of those. I could use a blank and then I will add my trigger. It also has complete kind of flows. It gives you some idea of what I might want to do. Oh, okay, we'll delete old blobs on a timer. Goes and does something to storage. HTTP request response. So I get a HTTP in, I do a HTTP out. I can see things. So someone creates a file in Dropbox. Well, let's copy it to OneDrive. Send an email when a SharePoint list is modified. All these different kinds of things. So here we go. Email yourself when you see tweets about a certain keyword via Outlook. Post to Slack. Deliver an SMT. I mean, all these different things, basically. So you can kind of pick all these different integrations or just create your own. Just start completely from scratch and do whatever you want. But it's all this kind of graphical view. I'm not coding anything. If we just pick something simple, for example, let's use this template. You can see, okay, well, it's going to show me the connectors it's going to use. So I'd have to go and add the connector. But it's all designed kind of in this view. I'm not coding anything. I'm really just dragging and dropping the components I want to make this so. And I would add those various connectors. So that's the point in logic apps. There's some trigger off of the thing, and then it will run that logic that I can define through there. They're the app services I'm covering. There are others. There's things like service mesh. There's tons of other things out there. I didn't talk about things like IoT Hub. I think today, for most people, from an app service environment, things like containers, things like IoT Hub use containers underneath. I think containers and the app services, they're going to be key ones, but certainly there are others. There's just only so many minutes. So we covered a huge amount. As always, I think it's probably 2 hours again. I apologize, but I hope this was useful. If there are questions, again, the goal is please go and ask in the comments. I'm keeping an eye on those things. So if I see it, I'll go ahead and answer it. But I really do hope this was useful. Please give it a like and subscribe. There's a huge amount of work goes into creating these. But until next time, take care.